Hi, this video is Lesson 3, Module 9, and we're going to be talking about compounds. Previously, we did atoms and particles and molar mass of elements. Now we're going to talk about compounds. So the molar mass definition, you have the molar mass of just in general molar mass, but we previously talked about molar masses of elements, which we can use the average atomic mass on the periodic table, and then 1 mole, for example, carbon. 1 mole of carbon is 12.01 grams. When we do the molar mass of the compound, we do have to take each element into account and multiply it by the number of moles of that element that are represented in the chemical formula, and then add those together. So, for example, cinnamonaldehyde is a compound that is found in cinnamon, and it gives us the flavor and the odor, and we can calculate the molar mass. So the difference here is that we have more than one element, and we can actually interpret these as moles. Simple way that I like to teach it is just to list the elements and how many of each element are in the compound. And then I look up the molar mass of that particular element. So, and remember, we're always going to go to the hundredths. So carbon is 12.01 grams per mole. Hydrogen is 1.01. And then oxygen is 16. So then it really is just multiplying and adding all those up. So I'll do it with you. Hopefully I don't have a... Okay, so I'm getting 132.17 grams per mole. So really, 1 mole of cinnamonaldehyde, C9H8O, is going to equal 132.17 grams. So we can do a conversion factor with that, just like we did with just the elements. So here's an example, another example. We are talking about caffeine, and the molecular formula for caffeine is right there. So in this question, we're given 1 shot of espresso has 27 milligrams of caffeine. So 27 milligrams, we want to enter the mole map here, so we do have to convert that into gram. And then after that, we need molar mass. So we would need to calculate the molar mass of the caffeine molecule. So we'll do that similar to what we just did. So we have carbon, hydrogen, nitrogen, and oxygen. In the formula, you can see that we have 8, 10, 4, and 2 moles of each of those elements. And then molar mass, I look on my periodic table, and then I just add all that. And I will do this with you if you want to try it with me. So I get a molar mass of 194.22 grams per mole. And remember, we can think of that as a conversion factor where really an first inequality. So 1 mole of caffeine, it has a mass of 194.22 grams. So I'm going to write that down here as a conversion factor. I'm going to put the 194.22 grams on the bottom and the 1 mole on the top. And you can see that with the dimensions or the units, this works. So first thing was to get the milligrams into gram. Once I'm in gram, the grams will cancel, and then you can see that I'm left with mole. And then on my calculator, You can do this however it makes sense to you. I tend to do this where I multiply, divide, and then I hit enter. And then I don't need to worry about using parentheses. So you can do yours and I'll do mine and we'll see if we agree. So I get 1.4 times 10 to the negative 4th mole. So 2 sig figs here, and then everything else is infinite sig figs, so that's why we keep the number of sig figs that we start with. Here's another problem. This is ibuprofen that is found in generic ibuprofen or Advil. So again, we can calculate molar mass, list those elements, and how many of each there are in the compound. Notice I'm going to the hundredths, and when I'm done with my molar mass, I'm going to also round to the hundredths. So when I add those together, I get 206.31 grams per mole. So a typical tablet of ibuprofen, let's say it contains 200 milligrams. So we would start with 200 milligrams, and we would want to convert that into grams. So then we enter the mole map, and then we're using molar mass to calculate moles. So my milligrams, that should be an M. My milligrams cancel, I'm in gram. So I need to put the 206.31 grams in 1 mole. And then you can see the grams cancel, I'm in mole. And we can calculate this. And when we do, with 4 sig figs, I get 9.694 times 10 to the negative 4th mole. You could also have it not in scientific notation, works too. All right, so let's keep going. So a typical bottle of ibuprofen is, a small bottle is 33 grams. How many molecules of ibuprofen would that be? So we're going to use that molar mass again. I'm going to be, so if I stop right here, I'm in moles of ibuprofen. So I really did this step here. But now I want to know how many molecules, so I'm going to go one more. This is my second step. And now I'm going to use Avogadro. 1 mole has 6.022, 10 to the 23rd molecules. And then I'm going to calculate. And when I do, I'm going to have 3 sig figs. So my answer is 9.63 times 10 to the 22nd molecules.